Can people hear me?
Yes.
Hello?
Yes.
You can
Yes.
hear me? Okay, let us start. Today we are going to the second chapter. Let me share my screen. So today we are going to look at chapter 2. That is the 8 puzzle. So in the previous chapter, we looked at the symbol crowning problem, and we tried to see that we base ourselves on various symbols to get meaning of various objects. But the problem stands on which grounds do we base to say that this symbol represents a cup, this symbol represents a fork, this symbol represents a man, this symbol represents a woman. And we saw a scenario whereby if a robot is designed and it is told whoever is putting on trousers should go to the men's door, and whoever is putting on a skirt or a dress is a lady and should go to the lady's door. Now a lady comes putting on trousers. So the robot automatically will think this is a man, and will take the lady to a man's door, will not open the woman's door. So we see there's a big problem there on basing on symbols to determine what you might think is a cup. To the other person, that symbol could be a saucepan. The question is, how do you determine that this symbol means this? So again, we are having another puzzle here, and it's called the 8 puzzle. We are building on the other challenge. And in a way, we are building AI thinking. We are building the way AI systems think. Recently, we had a debate on the group, and someone put a video of the other robots which are going into war. So we want to understand how was such a robot built to the extent we can go into a war. Okay, we no longer use human beings now in wars, but we use robots. But how are they built? What is the logic behind them? So this is what we are looking at, the logic behind these robots, such that we are able also to build ours. So the 8 puzzle system the 8 puzzle is a classic problem in artificial intelligence and puzzle solving research. When you look at this picture on the left, on the right here, this picture, we see that we have 8. We have numbers from 1 up to 8. But we have an empty space here, making a 3 by 3 matrix. So it is making a 3 by 3 matrix. But the slots which are numbered, they are from 1 up to 8. That means there's an empty slot here. And the purpose of this empty slot is to help us. Say, for example, if instead of having 4, 7, 2 up, if I want to have 8, 5, 1 up, okay? So currently the state is this, but there's a goal state which we need to reach to. But we are going to use this empty space to arrive at what we need. That is why we are left with one empty space. It's a 3 by 3 matrix, but we use only the 8, and then we leave one empty space. Now this empty space allows us to make movements to arrive at a certain goal. If you go to theology, people will tell you that God created us human beings and he put what is right and what is wrong. But he has left for every human being an opportunity to choose whether to do right or to do wrong. Yes, God has created what is right and what is wrong. But at the same time, God has given you an opportunity to choose what is right and what is wrong. So even here, we have this space gives us an opportunity to move these numbers until when we reach what we want to achieve. So it consists of a 3 by 3 grid with 8 numbered tiles and 1 empty space. 3 by 3 meaning if you multiply 3 by 3, you get 9. But we are using only 8 tiles and we are having 1 empty space. So the objective, mark this word objective. So the objective is to move the tiles into a goal condition. Into a goal condition. What do we want to achieve? What goal do you want to achieve? Okay? So that is our objective. When you are going to do research, normally, when you come to the research panel, we are going to ask you what were your research objectives. Why did you even engage into this research? So if our objective is to achieve a goal state like this one, the question is, how are we going to move? Okay. So in research, that is why you are going to be asked your methodology. Which method are you going to use to achieve the objective you have stated above? To achieve your goal, which method are you going to use? Okay. So by sliding them into the empty space, we shall see how we slide them into the empty space. So it is an example of a state space. State space means what is happening at a moment. So it is an example of a state space search problem and can be solved using AI search techniques. If you have a question, you unmute at any time and you ask me. All people are hearing me and you are following me. Are you hearing me?
Yes.
Yes.
So you are following very well.
Yes.
Yeah.
Okay, let's look at a problem states and a problem space. At first, the terms may seem to be a little tougher, but with the time, we shall get there. So, problem states and problem space. When you look at this diagram here, first of all, we have the initial state. Initial state, that means if you are given this puzzle here, it has a state in which it is. And this state in which it is initially, it is called the initial state. So our initial state here, it is arranged in in the format 1, 2, 3, 8, but our empty space is in the middle here. Okay? But all other tiles are numbered apart from the middle. That is the initial state in which we are. And when you go to do research, we ask you the problem statement. The problem statement. The problem statement signifies the initial state, the status quo of things. This is how things are. That's why we say in research, what do you want to solve? And you tell us the problem. Okay? And when I solve this problem using this methodology, then I'm going to arrive at, this will be the goal. So that will be the objective which you want to achieve. So the goal state is the objective which you want to achieve. And the problem now is this. We want to solve this in order to arrive at this. So initial state is the starting arrangement, of the tiles. That is the initial state. You mark these terms. They are very, very important and crucial. So the initial state is the starting arrangement of the tiles. That is the given starting arrangement. But then the goal state is the desired arrangement, is what you want to achieve, is the objective which you want to achieve. So if the starting point is this, and you want to achieve this, so this will be the goal which you want to arrive to. And that is what we desire. Now we have what we call the state space. Now the state space is the possible moves that you are going to make. And these we are calling them legal. We are going to see in examples down there, what is illegal, what is legal, and what is not legal. You see that some steps you can take, some steps you cannot take legally. For example, you may come to enter the university, gates, Nkumba University. Yes, you have the main gate, you have the gate at Nabagereka, you have the gate at Siad, and you have the gate at the law school. All these are gates which you can use. All these are possible moves which you can use. But then they are going to tell you that if you're a student, you cannot use the main gate. Okay? So that means now if you go into that gate when you're a student, that is illegal. So that is not a legal move. However much that gate can be used to enter the university, but for the student, it is illegal to use that gate. Then when you go to Nabagereka, again they say, only students who stay in Nabagereka can use this gate. Yes, you're a student, but you don't stay in Nabagereka. So it means it is also illegal to use that gate. So you cannot use the main gate because you're a student. You cannot use Nabagereka gate because you're not staying in Nabagereka. Okay? And when you go to the law school gate, they say only those who are doing law can use this gate. So that means if you're a student, you are doing law, and you are staying in Nabagereka, you can use either the Nabagereka gate or you can use the law gate. And then you are going to say the gate for Siad can be used by any other student. So it means if you're a student doing law, the possible gates you can use, if you are doing law and you are in Nabagereka, it means you have 3 possible gates you can use. You can use the Nabagereka gate, you can use the law gate, you can also use the gate at Siad. All those are possible legal moves you can make, legal gates. Okay? But remember, the main gate, you cannot use it because you are a student and it's not used by students. So that's what we call the state space. The set of all possible tiles configuration that can be reached by legal moves. Not any move, but the move should be legal. We shall see an example down there, how we determine a legal move. Then we have operators. These are possible moves, including shifting a tile left, right, up, or down into the empty space. Now these tiles, the tile we have seen up, you can slide it down. For example, you can slide down 1, or you can slide 5 to create a space. But you can also just lift it and place it here. So these are called operators. Like in mathematics, if you want to add 3 and 4, the operator you are going to use is the plus sign. If you want to subtract 3 from 4, the operator you are going to use is the minus sign. If you are going to multiply, the operator you are going to use is the multiplication sign. So possible moves include shifting a tile to the left. You can shift it up or down into an empty space. That is operator. The way you are doing it. Okay, what do you use? I said if there's a question at any moment, you can just unmute and you ask, or you can put in the chat room. Okay, continue. So our next slide there, we look at the moves and the preconditions. The moves and the preconditions. So each tile can move if there is an adjacent empty space. Now, this word is important here. We are looking at an adjacent empty space. So each tile can move if there is an adjacent empty space. If we look at the first diagram here, we are seeing an empty space in the corner here. So if the empty space in the corner here, remember we are talking of adjacent empty space. If you are talking of an adjacent empty space, that means only 6 and 8 can move here. So we have only 2 possible moves. Only 6 and 8 can move because the adjacent empty space is for 6 and 8. There is no way 7 or 3 or 2 or 5 can move. Now, when you come to this second diagram, we see that 7, 4, and 6 can move. You remember the scenario of the university gates, which gate a student can use. Then when you come to this one, it is in the middle. If it is in the middle, it means 2 can move. You can move 6, you can move 8, you can move 4. So legal moves depends on the position of an empty space. Remember the university scenario. The legal move was depending on whether you are a student or you are not a student. So that is a condition for the legal move. If you are a student, you can use either Navagereka gate, Siad gate, or Law gate. But still, if you are a student and you are not staying in Navagereka, then you can either use the Siad gate or the law school gate. But at the same time, if you are a student, you are not a law student, neither do you live in Navagereka, you have only one gate to use, which is the Siad gate. But if you are a student, you live in Navagereka, and you are a law student, that means you can use Navagereka gate, law gate, Siad gate. So legal moves depend on the position of the empty space. So if the empty space is in the corner, okay, if the empty space is in the corner, that is the first one we are seeing here. If it is in the corner here, only two moves are possible. Only two moves are possible. This move and that move. That is if it is in the corner. But if the empty space is on an edge, that is the second diagram here. If it is on an edge, but not in the corner, on an edge but not in the corner, three moves are possible. So three moves, you can either start by moving 7, or you can start by moving 4, or you can start by moving 6. You remember the other student who is a law student and lives in Nabagereka. So that student has the choice either to take Nabagereka gate, or to take the law gate, or to take the Siad gate. Now the choice depends on the student. Which gate will get the student easier where the student wants to go. But the student has an option of either Nabagereka, law gate, or Siad gate. And then, if the empty space is in the center, if it is in the center, then you have 4 possible moves. The choice is yours. Which one is first? We are going to see various methodologies which are used to solve this. So you can either take the move, you can start by sliding 2 down, or you can start by sliding 6 up, or you can start by sliding 8 or 4. Here you see that you are going to have 4 moves. In the first one, we had 2. We are limited. We have only 2 moves. You can move either 6 or 8. In the second one, we have more options. We can move 7, 6, 4. But in this one, we have more options whereby you can make 4 movements. Now, in our Nkumba scenario, you can have a student. The student is staying in Nabagereka. The student is doing law, but this student is a worker or is a staff of Nkumba University. Now, if the main gate was said it is for the staff, now this student is a staff, so it means he can use that gate. This student at the same time is staying in Nabagereka. It means he can use that gate. This student at the same time is a law student. It means he can use that gate. This student at the same time is a student who is a staff, so he can use the shared gate, which is used by anybody. Okay? Are things clear or they are becoming tougher?
They are clear.
They are clear.
Okay. So we go to the next slide. Let's look at the goal condition. So the puzzle is solved when the tiles are arranged in the correct order. So now when you look here, we have 1, 2, 3, 4, 5, 5, 6, 7, and 8. This looks to be a very nice order. Okay. But if this one is changed, okay, this is our initial state. But if you are to change, and we have 6, we have 5 there, then we have 2, we have 3, we have 1, then we have 8, what are we missing? 7, then we have 6. Okay. So this is now our goal state. Let me change the colors so that we can have different things. Okay. We have the first one is 1, 2, 3, 4, 5, 6, 7, 8. Arranged very well. But when you look at the second one, our goal state, we have 6, 7, 8, 4, 3, 2, 1, 5. So we want to move these tiles from this state to this state. The 6 which is here, we want it to come there. Okay? So we want to move the 6 to go up to there. And then the 7, we want to move it up to there. Then the 5, we want to move the 5 to make sure it is there. The 3, to move it until it is there, and so on and so forth. The question is, how are we going to do it? How many steps do you see we can take at first? Who can tell us the possible steps we can start with? Anyone who can tell us? Someone is typing in the chat room. I want someone to unmute and you talk. Can someone unmute and you talk? All I call names. I'm seeing a debate in the chat. Someone says 3 steps, and another says depends on which number you would like to start with. No, the first question is, how many steps can we take? First, forget about the it depends. The first question is, how many steps, how many moves, how many legal moves are available for
Two.
you? Hmm?
Two.
Yeah.
Two.
Three possible steps.
Okay, let us go slowly. Someone says 2. Why do you say 2?
Because
What?
the initial one has, you can either move 6 or 8.
No, but we want to arrive at this goal. Forget about the initial state. Okay, that is the initial state. But our
I
goal
think
is this red one.
for me, I said there are 3 possible steps.
Why?
We have 3, which can be moved to the empty space. We have 5, and then 1.
Yes. So at first, we have 3 possible moves. So we can either move 3 down, we can move 1 to the right, we can also move 5 to the left, right? Now, if we do that, if we do what our brother said, let me just do like this. Okay. If we just do what our brother said, so we want to move. But the question is, what do you want to start with the movement? Okay. So if we move, let's start, for example, with the 3. Okay. And we move this 3 down here. That's a minute someone here wants to talk to me. Okay, so we had two people who presented. We had a person who presented who said 2 steps and another said 3. So we want to look at both of them and we determine which one is correct. So I began with the second person. So the second person says we can move this 3 down. We can also move this 5 here. We can also move this 1 here. Okay. So the second person, that's what you were suggesting, right?
Yes,
Oh,
please.
yes. That's what you are suggesting. Now,
Yes,
my
that's what
question
I
is, okay, my question is, let us go back to this slide. For you, you are starting at a goal state. And this is the biggest problem many of students do in research when they are doing research. And some of you, this is what you are going to do. You are going to design a system, then you start working backwards to find the problem. Okay? We shall see these steps ahead. We shall see some people work backwards. So for you are beginning from the goal state. Okay? Some people begin from the goal, but we are saying the initial state. How do you arrive at this state? Okay? How do you arrive at this state? Now, if you begin from this goal, you are going to find problems because at the end of the day, you have to come back to this goal. And that is the problem of going to research when you know the results already. Okay? Do you get my point? You go to do research when you already know the results. But when you look at the first, if we consider the first person, what the first person said, let me first remove this. So when we look at what a first person says, now this first person wants to arrive at this, but she has this stage here, this step here. So for her, she's not beginning from this stage, but she's beginning from this stage in order to arrive at the other one. And she's saying, I can move this 6 from there and I put it here. That is one possible move. She's also saying, I can move this 8 from here and I put it down there. Okay? So these are 2 possible moves. We have this move. That is when the 8 is moved. And then we have the other move when the 6 is moved. Okay? So these are 2 now possible moves that she's having. So when you look at these possible moves, it means this person is already on the way to achieve this one. I hope you get the difference between the 2 presenters, the first one and the last one. We want to make a clear and confident decision. Should we move from the first presenter or use the method of the second presenter?
So I have some question.
Ask, please.
Yeah, I thought that now when we are going to solve the puzzle, Our main goal is to reach at 1, 2, 3, 4, 5, 6, 7, 8, like the puzzle to be arranged in order. Then the other one is what you are presented with.
Okay, yes, you have got it the other way around. So we are saying our state, this is our initial state, the black one, 1, 2, 3, 4, 5, 6, 7, 8. That is how the puzzle has been given to us. Okay?
Yes.
And that is the initial state.
Okay.
That is the initial state.
The one in red is the goal state.
The one in red is the goal state, is where I want to arrive to.
Okay.
But if the one in red was our initial state and we want to arrive at the black one, then there you do have the other three choices. Okay.
So we use the one in red now.
No, for us, we want to move from black to red. That is our intention, to move from black to red. So we want to move from 1, 2, 3, 4, 5, 6, 7, 8 to a state which has 6, 7, 8, 4, 3, 2, 1, 5.
Okay, I get to the point now. Yes, please.
So now we are agreeing that this one of the two steps is correct. Okay?
Yes.
By the you'll find such scenarios in the exam. It requires a bit of some reasoning. We shall see, we have a chapter on reasoning and we shall see how these things work. So now, after we have had two possible moves here, okay? Now again, we have not yet arrived where I want to go, right? We have not yet arrived where I want to go because where I want to go is this, and we have not yet arrived there. We want to arrive at a point where this space here is empty and we have a 3 up here, okay? So it means we are still moving these slides. We are still moving them. So we can begin, when we come to this one, now we have two ways. We can either move this 6 up, okay? Now, but when I move this 6 up, I'm going to go back to the first initial stage. Am I moving? No. Do you get the logic? I have the option to get this 6 away, okay? And I move it up. Okay? Now the question is, if I move this 6 up, am I not going back to the initial stage? In principle, will you be progressing? Will you be advancing?
No. No.
No. You know, there are these people in church who does this, those Catholics who does this offertory song, Agutamba. You be in church, they go 3 steps forward and they go 2 steps backwards. They go 3 steps forward, 2 steps backwards. When will you ever reach where you are going? You see? So if we take this move, it is not going to be the best move because it is going to take us to the next back. And again, we are going to call 8 here. Okay? So that means that one is not the best move we can make. Okay? So it means we are going to discard this. But when we come to this one, again, we have an option of bringing 8. We have an option of bringing 8 here. Okay? Now, if we take that option of bringing 8 here, are we progressing? Because remember, 8 has come back in where it was. So we are not progressing. So which means that one is also a wrong move. It means we leave our 8 there and we cannot move here. So it means now this move here, we are not going to use it. It means this one, we shall not use it. Because we don't want to waste our energy on this one. So we are going to move this, but when we are using this move, it means still the 8, we cannot touch it. Because if we touch the 8, it means we shall not be progressing. So it means the 8, we cannot touch it also. So if we are saying we cannot move this one and we cannot move the 8, the only two options we are left with is moving 5 and moving what? 7. Does it make sense? So we have two
Yes.
options. We have two options now. So if we proceed here, I want to get this. So it means we are left with two moves here now. And the first move is we can bring this 5 down here. Or we can bring this 7. We can bring this 7 there. Okay. Does it make sense? But we are not yet there. So the process continues until when finally we get here. Okay. So in my next slide here, we have what we call basic production system for solving the problem. So we want to look at an implementation of this. The basic production system for solving the problem. So we look at industries, how they operate. Okay. You have water, you have wheat. Okay. You have water and you have wheat, but you need to produce beer. Okay. You have water, you have wheat, but you need to produce beer. Okay. So our present state, we have our raw materials, that is water and wheat. But our goal state is to have a product which is called beer. So the global database maintains the current state of the puzzle. So global database, you take it as the raw material, okay? And it has the current state of the puzzle. Current state is we have water and wheat. Then operators, production rules, defines how state transitions through legal moves. So how legally are you going to transform this water and wheat into beer such that tomorrow or the other day, UNBS is going to certify it and says, yes, it is good for people to take. So that is the operators, that is the production rules. Which rules are you going to follow to transform this water and wheat into beer? Okay. Then we have what we call the control strategy. So control strategy determines the order in which states are explored. So when you look here, there's a control strategy we have looked at. The control strategy here, are we moving 8? If we move 8, we shall go back to, so we are controlled. Because when we move 8 on the left, we are going back to the initial state. And here, if we move 6 down, we are going back to the initial state. So this now controls us. We cannot use this to move 6, neither can we move 8 to this side. So we are only controlled in the way that we can either move the 5 down or the 7 down. Even NBS is going to tell you that when you are producing beer, which is going to be taken by human beings, you must do it in such and such an environment. For us to certify your beer, you have to have a clean environment. You have to do this. You have to wear like this. You have to cover your head if you are producing food. So you are controlled. There's a strategy which controls you. You don't do things the way you want. Okay? Then rule preconditions specifies conditions under which moves can be made. Again, we go back here. Still, those conditions are there, which we can use in order to reach what we need. Then termination condition, that is the start stops when the goal state is reached. So when we reach here, we don't move any further because we have reached the goal state. Likewise, if you produce beer, then you don't need to go further. You just need to put it into the bottle and then you take it to the market to sell it, because your goal was to produce beer. And now you have the beer. At first you had wheat and water. Now you are through all the steps, the conditions, the operators, the strategies, the rules, and so on. You have followed all of them very well. And at the end of the day, you have a product which is called beer. It is no longer water, it's no longer wheat. You have the product called beer. And now this product, that is the termination condition. At that stage, you have terminated the process and you are saying here is the beer and you are taking it to the market. And that is now called the stopping stage or the termination condition. And this is how AI works. We are going to see this in practice as we go ahead. Things are tougher. Oh. Are we building our understanding of the 8 puzzle? All things are just confusing them more. Okay. Silence either means yes, we are understanding, or it means we are now completely lost.
Sir, is it okay if you again try to go through that upper slide 8? I was trying to, yes, that slide 8 there. It's trying to combine those points from the goal, the global database up to termination condition, but
okay, when we say a global database, right? I'm going to give you a scenario. I want someone who has graduated in Bachelor of Information Systems and Technology, right? That is my goal state, is to have a graduate of Bachelors of Information Systems and Technology. That is my goal state. Now, globally, when you look globally, there are so many students who have done senior 6, right? That's now the global database. And all these are potential candidates to do a bachelor's degree in information systems and technology, which I want to get. When you see, say, for example, last year, how many students sat senior 6? Now, of those who sat senior 6, how many passed? Then we say 30,000 students passed senior 6, or they are eligible to go to the university. Okay, now that is a global database and contains the current things, the status quo. All these 30,000 students have qualified to do a bachelor's degree. Okay, but now defines how the rules. We are going to define now the rules. Now the rules are going to start. Yes, you are 30,000, but who have qualified to do a degree. But we are saying for us to do Bachelor of Information Systems and Technology, you must have got 14 points. Okay, that is a rule already. Okay, and now we are going to put, you are going to say, okay, 20,000, go to the 14 points. Now we are going to put a control strategy. A control strategy, now we are going to say, out of the 20,000, we are going to look at those who did physics and mathematics. And maybe could have added fine art or could have added biology. You see, again, we are limiting. Okay. So we go on and go on and go on until when we get the actual students who are going to do a bachelor's degree in information systems and technology. Another simple example I can give you is the interview. When they advertise a job, they are going to advertise and they say, we need an IT manager. But the IT manager we need, these are the qualifications we need. So when they list the qualifications, then you're going to get 200 students who are going to apply, saying they have their qualifications. Now, when you go to the process now of shortlisting, in the process of shortlisting, they are going to say, yes, all the 200 have a bachelor's degree in information systems and technology. But now we want to, those who got first class and upper first class and upper second. Okay. All of these are controls in order for you to arrive at the whereby you are going to get the manager for information system and technology. After getting those who got first class and upper and second class upper, again, if there are still many, you say, hey, there are many. Now let us go only to first class. When you go to first class, you realize that yes, you have first class, but some have 5.0, others have 4.8, others have 4.7. Then you say, now let us look only between 4.8 and 5. Okay. So rule conditions. Okay. Yes, you can give rules, but these rules can be controlled and these rules have conditions. Okay. Until when finally you come to the goal, which is getting the IT manager. Finally, you say, after following all the rules, the conditions, and so on, finally, we have so and so as the, or you shortlist and you say, now we have 6 who are coming for the physical interview. And then also from the physical interview, also you go back and you set rules. Now the 6 are going to become the global database. Okay. The six are going to become the global database. Also, you put conditions, you put rules for them until when you have the one. I don't know if it is making some sense now. Is it making some
Yes,
sense?
making some sense.
Okay.
There is sense there.
So the search strategies for solving the 8 puzzle. Okay, it is going to become more clear when you look at these strategies. So we have several AI search strategies can be applied to solve the 8 puzzle. We have what we call the uniformed search strategy and informed search strategy. Sorry, uninformed, not uniformed, but uninformed search strategy and the informed search strategy. These are 2 strategies. When you look at the uninformed, it has what we call the breadth first search. And this one now is going to explore all the possible moves at each depth before proceeding further. Let us go back to the scenario of a student at a university. He comes to the university and is going to explore. Yes, I have come to a university, but I want to use the main library. My goal is to use the main library. And this student sees that the easiest way of going to the main library is to use the main gate. Okay? But when you reach at the main gate, you are told, since you are not a staff, you cannot use the main gate. Now, the question is, you are left with the Nabagereka gate, Siad gate, and the law school gate. The question is, of the 3 gates, which gate is going to take you first to the library? If I use the Nabagereka gate, will I arrive so fast at the library? If I use the law school gate, will I arrive first? So it explores all possible moves at each depth before proceeding further. So you look at the Nabagereka gate and you debate yourself. Yes, I can use the Nabagereka gate because I'm a law student and I stay in Nabagereka. But if I use the Nabagereka gate, will I reach so fast at the library? If the answer is yes, I go ahead. If I use the law school gate, will I arrive so fast at the library? Because all of these are possible. So that's why you say explores all the possible moves at a depth. Depth means going into details. Okay, deep down into details. Okay.
Yep.
Before you proceed,
Yeah.
that is what the depth means. You go into details. You look at the Nabagereka gate into details. If I enter Nabagereka gate, yes, I may reach faster to the library, but there is a friend of mine near.
What
In the moment I enter, I'm going to find a friend and we shall
Unfortunately,
start
it was in my
conversing.
hand. I don't know if it was in another hand.
Someone is lecturing also there. Okay. Then when you go to the depth first search, explores one branch deeply. That is what I've said. explores one. Now, you explore the Navagereka first deeply and make sure it is either working for you or not working for you. If you find a Navagereka is working for you, you go. But if you think it's not working for you, you go back and now look at SIAD. If it's not, you go back. Okay? You explore one, then a uniform cost search expands the lowest cost node first. So you have 3 gates. You look at the lowest. Now, when you look at these 3 gates, Navagereka is closer to the library. So before thinking of go to the low gate, that means first think of Navagereka gate. If Navagereka gate, you explore and find that this gate here, if I pass here, maybe I don't even have where to park my car. I'm going to find students are going to distract me. There's someone who lent me money. If I find that gate, if I pass into this gate, that person is going to start saying, you, my money, my money. That is, you explore the lowest cost node first. You expand it first. We are going to see this in the next slide. Then we have the informed search strategy. That is the grid-based first search. Expands the node that appears closest to the goal. Now here it comes from the word greedy. Some people are so greedy to the extent when you see money, you don't even need to know where this money comes from. For you want to grab it and take it. You don't know whether they are going to take you to prison, where this money is leading you to prison or what. No. So some people are so greedy that what he sees first, you see, some people when they go to serve food, he wants to take the biggest piece he sees on the top. But what do you know that maybe the sweetest piece is the one which is at the bottom there. But because for you are greedy, you are seeing the biggest one, you say, I need that one. But when you go to eat, you just one bite and say, this piece is not good. After it's too much salt. But a good one, you left it down. Okay? So some people are so greedy that for him, he wants to take this greedy approach comes from that element that what is closer to you is what you want to take. I don't want to use the scenario of boys. Sometimes they are so greedy that the first girl they see, they want to run for that girl. And yet, if you take your time, you'd find the best girl to marry. But the moment you come to the university, the first girl you see, that one, then you start running. But as you are still on that one, girls are still coming. The university has just opened. Okay. So that is the greedy. Then a search algorithm uses both paths, cost and estimated cost, to the goal, that is heuristic function, to determine the best move. We shall see the heuristic function also as we go ahead. Okay. Let us first understand the uniformed search. So the uninformed search, that is the breadth, depth, and so on the uninformed search. Let us first use this example to understand it. Okay. So when you look at this, I'm going to give this and I'll end this lecture here so that I don't confuse you. Then the other slides, we shall use them in the other lecture. Someone is putting in the chat room. A heuristic function is a problem-solving shortcut used in computer science and artificial intelligence to estimate the best path towards. Yeah, we shall see an example of a heuristic function. Yes, what you have put is correct, but we shall see an example to get it to understand it further. Let us first understand the uninformed using the best first search. Now, look at this picture here, the first one up here. Okay. Let me. Okay. So when you look at that first one up there, okay, we have the initial state, and our initial state is given as 2, 8, 3, 1, 6, 4, 7, space 5. That is our initial state. And what we want to arrive at is 1, 2, 3, 8, 4, 7, 6, 5. That is our goal state, is what we want to arrive at. Okay? Now, we are looking at the possible moves which we can do. If you look at our initial state here, the empty space, which is the black spot here, is on the bottom. Is on the bottom. And where it is, it means we have 3 possible moves. We can either move the 6 down, and we have empty space where 6 is. We can either move the 7 to the right, and we have empty space on the 7, or we can move 5 to the left. Okay? So when we come to this diagram here, these are the possible moves which we can do. We can either move the 6 down, and then we have the black spot. We can either move the 7 to the right, then we have this state now. We can also move. So that is the first state. So our second move here is to move the 7 to the right. Okay? So that we have the empty space there. And also, we have an option. All these are on the same level. Okay? So we have 3 moves we are making. But now when we reach this stage here, the matter has now become complex. Okay? Because now we have more moves. But when we look at this one has 2 moves. We can either move up or we can move to the right. But when we move to the right, we can either move 7 back. Remember, we said there's a wrong move. If we move 7 back to the left, that is a wrong move because we shall be going back where we were. So it means that move, we cannot do it. Remember, this here where I said this 8 here is a wrong move. If you move the 8 back, we are not moving any progress. Okay? So it is a wrong move. Like when I give you a retake, you are not making any progress. It means I've taken you back where you were. That's not because you want to move, you want to graduate. But now this retake here is taking you back to the state where you have been, and you're not making any movement. Okay? So we said this 8 here is a wrong move because it is taking us back where we have been. Okay? Now someone is putting in a chat room, I don't know. He's saying that is true. Let me not complain much about the retake. Let us understand what we are understanding. Okay, so we are saying here now we are discussing, we are discarding the movement of the 7 because it's going to take us where we have been. So we are taking now the movement of up. So it means here instead of now having 2 movements, we have 1 possible movement which is going up. And when we come here, again we have 4 possible moves. But out of the 4, it means we cannot move the 6 up. If we move the 6 up, again, we are going to be going back into the state where we have been. So it means that is the wrong move now. So we are left now with the 3 moves. So the first move we have, we can move to the left, we can move up, we can move to the right. Okay? Automatically moving down is gone because we shall be going back to where we have been. Again, when we come here, we have 2 possible moves. We can either move this one to the right, or can move this one down. But when we move this one to the right, we shall go back to where we have been. So it means that one is also not possible. So the only possible is to move up. Okay? And so on and so on. The process continues until when we have this final one here, which is the final stage. We are going to reach it when we reach at 46 here. Okay? So we are going to make 46 moves And on the you'll find that on the 46th move, that's when we shall have the right turn. If you go back to a scenario of the brewery where we have water and wheat, you will see that they are going to take stages. The first stage will be to purify the water. Then the second stage will be to purify the wheat. Then I don't know the processes they follow. Then the second stage will be this. If you go back to university scenario, you have come to year 1, and the first stage is attend first semester course units and do them, finish them. Now, when you finish them, go to first year, second semester. But if you have a retake, this retake is going to take you back to the first semester, and it is stopping you from moving. That is why you see in the law school, unlike other schools, but when you go to the law school, when you get a retake in any course unit, you cannot proceed to the second semester. You have to go back and first do that retake. You cannot proceed to a second. You cannot say, I'm in the first year, second semester when you have a retake in the first year, first semester. You have to first do that retake and make sure you have passed all the course units in that semester. That's only when you can go to the second semester. I think that's a good practice, which other schools can do as well. What do you think? Suraj, what do you think? Is it not a good practice?
I am not
Watch
thinking.
away.
But it's good.
I have refused to think.
I have refused to think. I think I should advise the university to do it that way. When you
We
get a
shall
retake,
object.
you first
No,
do
no,
it.
no.
Not really.
Oh no,
So
I
what if
think
we have an newspaper?
I think
We shall object.
no, I think no. Already someone can do help us to do research. Your final year project, you can do that. You can design a system for Kumba University such that when a student has got a retake in a course unit, he cannot proceed unless he has first passed all the course units. You can develop for us that system. The moment they put your marks and you recognize a retake, it stops there. There's no way you can enroll in second semester.
Hey.
You see?
That's again dangerous.
What is it dangerous?
We have not agreed, by the way.
You and who?
All of us, we are not agreeing with you.
By the way, that is a such topic someone can work on, and then you can come up with that system.
No.
And then you see students reading so hard.
Just tell us you don't want us in school.
Someone said, just tell us you don't want us in school.
It's not good, sir.
Someone say, why are you being like that? No, I'm just suggesting. I'm not saying I'm like that. I'm just suggesting. So,
suggestion brings an idea brings an outcome. We are not safe.
Please keep that suggestion.
However, it may be good in another way because it may
at least I've got someone
also
supporting it. At least there's someone supporting it. So, I think we have understood. I'm going to stop at this point today.
Okay.
And I hope people have understood these things. Because if we don't understand them, the exam will become a problem, and people will blame me for nothing. Have we understood the concepts?
Yeah, we have got the concept, and it's a process we shall be getting very well.
Now, I'm going to send you, after the lecture, I'm going to give you a YouTube video, which is going to help you understand the last example of the best search first. I'm going to give you a YouTube video. Follow that person, how he does these things. Just follow that video very well, and then set a scenario for yourself, and then you practice it. Okay?
Yes.
Follow exactly how he's doing it. It will help you to understand it better.
Okay.
Yes.
All right, sir.
I have recorded this lecture. It will be available on my YouTube channel. In case you need to do some revision or to go back slowly by slowly, I have recorded it. Those of you who don't know
All
my
right.
YouTube channel, you just go to YouTube and put there Richard Kauma. You'll see my YouTube channel and you see the lecture will be there shortly. I'm going to upload it after here. Any other questions?
Okay.
Yes? Do you have any distance students online?
Yes.
Yeah, you missed a physical lecture. Now, for those of you who can manage, tomorrow I have the same, I have for the weekend students, the same things I'm going to teach, but physical. It will not be online. Tomorrow, I think, I'm not sure, but is it in after lunch or any weekend student online? Anyway, I'll post the time in the group. I'm not sure.
It's after lunch at
It is
2:30.
It is at 2:30 tomorrow, right?
Yes.
Yeah.
Yeah. So those of you who want to attend it, I'll be physical tomorrow in WAVA 3A. WAVA 3A. That's where we shall have it. It will be physical, but I'll be teaching the same things. In case if you want to understand it more, you can attend if you have not understood it.
Okay, sir.
But it will be exactly the same matter taught, but physically, not online. Okay. I wish you a nice day if there's no other questions.
Okay, enjoy your day too, sir.
All right.
See you tomorrow.